Okay, welcome back, and we're going to do an example of testing for symmetry with on the polar grid. So here's our polar equation, and so let's test to see where it's symmetric. So the first thing we'll test is to test the line theta equal to pi over 2. Okay, and so we're going to replace r with opposite of r and theta with the opposite of theta. So we're going to get minus r, negative r equals 2 sine negative theta. And now we're going to use the fact that sine is an odd function, and we know we can rewrite this as negative r is equal to negative 2 times sine theta. Which then, of course, if we divide both sides by negative 1 or multiply both sides by negative 1, we get the original equation back. And so this shows us that this polar equation is symmetric with respect to theta equal to pi over 2. Now, what about the other ones? Well, let's do the polar axis. So now with the polar axis, one of the things we could do is to replace it with the opposite of theta. So that means we'll get r equals 2 sine of the opposite of theta. And again, because sine is an odd function, we can write it as the negative sine of theta. So this becomes r equals negative 2 sine theta. Now in this case, we don't get the original function back. We get r equals the opposite of the function. So it fails this test. Now, this does not mean that it's not symmetric with respect to the polar axis. Okay, you could say it's inconclusive. Okay, so now what about the next one? What about the pole? Okay, well, let's test that one. So now with the pole, we're going to replace r with the opposite of r. Okay, now, as you can probably guess, it's going to fail. So we're going to go negative r equals 2 sine theta. And again, we multiply both sides by negative 1, we're going to get r equals negative 2 sine theta. And of course, it fails. Right, we don't get the original equation back. Okay, so it may or may not be symmetric with respect to the pole. Okay, so again, just because it fails the test doesn't mean that it is guaranteed not to have that corresponding symmetry. But we do know that it does have symmetry with respect to the theta equal to 1/2. Okay. In fact, if you graph it on your graphing calculator, you'll get something that looks like this. Okay, where it's symmetric with respect to pi over 2, right? Again, my picture notwithstanding. Okay. And it'll have, it'll go from 0 to 2. So this goes from 0 to 2. So it's a circle that starts at the origin and goes around and comes back to the origin with a diameter of 2. So it has a radius of 1. Okay? And it's centered at 0, 1. Okay. Have a great day.